Hey folks, welcome back to my kitchen. We're going to be doing another lesson today in here. We're going to be looking at how heat is transferred from one object to another. So two key terms that we're going to look at is radiation and conduction. So both of these are different ways that heat energy can be transferred from one object to another, and we're going to be at my stove looking at that. So buckle in, we're about to go. Alright, so we're here at my stove. The first thing that we're going to cover is radiation. So radiation of heat. Every object in the world radiates heat, even the cold ones. It's just different levels of that radiation. So radiation defined is the transfer of thermal energy by electromagnetic waves. So if I turn on my stove, turn it on to high, it's going to start heating up. So what I'm doing is I'm transferring this electrical energy into thermal energy, which is being released in radiation, released in electromagnetic waves. So that's why when you get closer to something that's hot, see, I can feel the heat from here. So the radiation away, that transfer of thermal energy through electromagnetic waves is hitting my hands, and I can feel it from all the way over here. So that is radiation. Now I have my little pot that I used yesterday for our video. And now we're going to look at conduction. So conduction, a lot of times you can think of that as electrical conduction. So that's the same idea, but we're going to look at thermal here. So thermal conduction. Defined, conduction is the transfer of thermal energy by collisions between particles and matter. So yesterday we talked about how in solids like this pan, the particles in that state of matter are very closely packed. They're densely packed and there's not very much energy in them. So that dense packaging is optimal for conduction of energy. So conduction, the heat will hit a particle, start to make it move and bump, and it's going to hit the particle that's next to it, so they both start vibrating. So conduction, when they're tightly packed like that, works very well. That's why solids are the best conductors. So we have this pan, put it on here, I'm going to let it heat up. It was cool to the touch. I can already feel it getting warm. And so this radiation, I can still feel it on the sides. Radiation, so the transfer of thermal energy through electromagnetic waves, I can still feel. But there's also conduction. So the heat from the stove is hitting the particles in this pan, and those particles are bouncing into each other. As they bounce into each other, it transfers that thermal energy throughout the object. So we'll wait a little bit longer. Since it's been on this hot stove, the conduction of that heat has gone through this pan. Hopefully we will get a nice sizzle as it also goes into this water. So this dish did not create the energy. The energy was not that source. It was conducted energy. The energy of the stove conducted through this solid metal, which transferred the energy into the water that's inside. We're going to look at this on paper, and then we'll have an assignment on what this is. Alright, so first thing we're talking about, when we are on the stove, this is my makeshift stove, a little fire here, and the pan or pot's on top. We were talking about radiation. So this flame down here, radiation, remember, is the transfer of thermal energy through electromagnetic radiation. So this fire is going to be, I'll use red for heat. Nice. This is my fire. It's going to be emitting electromagnetic waves from the source. And this is why if I had my hand like right here, I would feel the heat. So it's transferring the thermal energy from this source through electromagnetic waves. So it's emitting that heat, and it hits the pan or the pot that's on top of the stove. So it hits the pot. What's happening at a molecular level, bring these suckers back out. Looks like I'm missing one. All right, so this is our solid. the particles are tightly packed. There is a high density, low energy. So the energy from the flame comes up and it hits these particles. So these particles on the bottom, they get hit with it first. They start vibrating. While they're vibrating, they will go up and they'll hit these particles. So they'll start vibrating. And in turn, they'll hit the particles above it, and they'll hit the particles above it, and the heat will just continue to transfer up through the object. So the reason that solids make the best conductors is because they're tightly packed like this. Because if we had a liquid, they're spaced further apart, so the heat would hit, and they'd have to vibrate a whole lot more before they had the chance of hitting something else. We look at a solid, they get hit, they vibrate, they hit the other particles that are next to it. So, conduction. The thermal energy is transferred by the particles making contact with each other, or making collisions of the particles in between each other. So solids have the best conductivity. All right, so using these two examples, we can do the homework for tonight. If you have any questions, please feel free to email me or request a Zoom call even. I am open to you guys between 9 a.m. and 3 p.m. Good luck on this.